Sanger, Dr. Sanger, and he found out a way using DNA replication and a very dirty technique with radioactive labeling that made us able to read DNA on base pair resolution. So on the right side you see one of his first gels. It is all the bands in the gel are different positions of DNA, and you can read the codes. You can, when you start at the left side, you can see that there are two bands in the G row, and then there's one in A and another one in G. So using this type of graphs that you could read DNA structures. So yeah, now we had the ability to cut and paste DNA and to read it. After that, a major breakthrough was done by this guy, Gary Mullis. He's the inventor of polymerase chain reaction. That was done in 1983, and it's a methodology for copying DNA really quickly. So you can, using this method, you can start with one piece of DNA and then copy it into billions. And that's really useful because then you can cut that piece of DNA and paste it into another piece. And that's easier when you have billions than when you only have one piece of DNA. Because one piece is very hard to find and to cut, but if you have a tube with billions of the pieces, then this goes pretty fast. And nowadays, yeah, we have lots of different methods for reading DNA. On the top there are the machines that are most used, the 454 sequencer. Then in the middle, the Illumina sequencer that uses fluorescence, and on the right, the Ion Torrent. It actually has a mount for an iPhone in it, so you can read DNA with that machine based on electrical signals. And some people are dreaming at a company called Oxford Nanopore. They're trying to make USB pump drive DNA sequencing machines, but they don't really exist yet. This is just a concept, but who knows? At least in Beijing, they have this Beijing Genomics Institute, and they have rooms full of those machines, and they are sequencing DNA at a high pace, which has resulted in an explosion of the amount of DNA that we have in databases. This is GenBank. This is like the most frequently used database of genomes in the world. You can see this hockey stick curve that kind of started when DNA sequencing became affordable somewhere in the 2000s around the Human Genome Project. And after that, every year, this is a, you can see that every year there are now 10, 20 million new sequences added to the database. So you can imagine there's a huge amount of machines reading